This is Euclid Book 10, proposition number 62. The square on the second bimedial straight line applied to a rational straight line produces as breadth the third binomial. Let AB be a second bimedial straight line. That's this one right here. And it's divided into its medials at C, so that AC is the greater segment. This one's longer than this one. And let DE be any rational straight line. That's this one. And to DE, let there be applied the parallelogram BF, which is this whole thing across here, equal to the square on AB. So this whole area right here is going to be equal to this. And producing DG as its breadth. That's this line right across here. I say that DG is the third binomial straight line. Let the same construction be made as before shown. Then, since AB is a second bimedial divided at C, therefore AC and CB are medial straight lines commensurable in square only, and containing a medial rectangle. Okay? So these two lines are only commensurable in square, and they do contain a medial rectangle. This is by Euclid Book 10, proposition number 38. So if the sum of the squares on AC and CB is also medial, we add these two areas together, that'll be a medial area. This is by Euclid Book 10, proposition number 15, and Euclid Book 10, proposition number 23, porism. And let it be equal to DL. Okay. So if we add these two areas together, it'll be the same area as this plus this. These two areas combined will be the same thing as these two areas right here. Therefore, DL is also medial. This whole area is medial. And it is applied to the rational straight line DE, as you can see right here. Therefore, DM, this line right across here, is also rational and incommensurable in length with DE. This line is rational, but it's incommensurable in length with this. This is by Euclid Book 10, proposition number 22. For the same reason, MG is also rational and incommensurable in length with ML. Okay, so MG and ML, okay, MG is rational and is incommensurable in length with this. Alright, and since ML and DE are the exact same length, then MG is incommensurable in length with DE. Therefore, each of the straight lines DM and MG, this line right here and this line right here, they're both rational, and both lines are incommensurable in length with DE. And since AC is incommensurable in length with CB, so since this line is incommensurable with this line, and as AC is to CB, as this is to this, so, okay, scratch that. As this line is to this line, so is the square on AC to the rectangle ACCB. Okay. Let me say that again. As this line is to this line, so is this is to that area. Therefore, the square on AC is also incommensurable with the rectangle ACCB. These two areas are incommensurable. Hence, the sum of the squares on ACCB is incommensurable with twice the rectangle ACCB. So if you add these two areas together, that sum will be incommensurable with twice of this area. That's by Euclid Book 10, proposition number 12, and Euclid Book 10, proposition number 13. That is, DL is incommensurable with MF. Okay. This whole area here and this whole area here, they are incommensurable. So that DM is also incommensurable with MG. Okay. DM and MG are incommensurable. This is by Euclid Book 6, proposition number 1, and Euclid Book 10, proposition number 2. DM and MG are rational. This line and this line are rational. Therefore, DG is a binomial. This whole line is a binomial. It is to be proved that it is also a third binomial straight line. In a manner similar to the foregoing, we may conclude that DM is greater than MG. The length of this line is bigger than the length of that line. And that DK is commensurable with KM. This line and this line, they're commensurable. And that the rectangle DKKM, that's this one right here, is equal to the square on MN. Okay, so the area inside of here is the exact same area as if we were to take MN, this line MN, and make a square out of it. So this area here is equal to that area there. Therefore, the square on DM, okay, if we were to take this line and make it into a square, is greater than the square on MG. Okay, so the area in this square is greater than the area in this square. And how much greater is this area over that one? This one's bigger than this one by the square of an area of a straight line that is commensurable with DM, which would happen to be DE. And neither of the straight lines DM and MG is commensurable in length with DE. Therefore, DG is the third binomial straight line. This is by Euclid Book 10, the second set of definitions, number 3. And thus ends that proof. I will tell you more in a future video. Stay tuned.